I'm going to talk about primarily the sources of stone tool raw materials and looking at different ways that we can reconstruct the territories of groups in the past and also the interactions between groups in the past. So, like I said, the science part is a bit more of a means to an end in this case. I've made this presentation sort of more accessible for general public. So for those of you who are, really into stone tool raw materials, well, you'll have to wait till the end to ask me the questions. Anyways, in archaeology, as many of you know, we often find stuff that comes on our sites that comes from far away. I might be working at Alamet Island and the Ottawa River there and find copper that comes from Lake Superior. Perhaps I'm excavating with my colleague Yves Capien in Quebec City, and he found 180 bifaces all made of Onondaga dirt, and that's a good 800 kilometers away. Or I might be excavating in Bas-Saint-Laurent and find a large biface made out of a Rama quartzite. This is actually a pretty common occurrence for archaeologists on their sites, on pre-contact sites. I've given, these examples are obviously a little more showy and a little more kind of impressive because of the distance we're talking about, but nonetheless, it is a common occurrence to find materials that are not from the immediate area of a site. Now, this is something that most people know who are interested in the history of Canada. This image is from Jim Wright, made this plate for the history of the Atlas, Historic Atlas of Canada, Volume 1. And he, as you can see, he showed, the movement of Rama. He shows the movement of copper, of Mistassini quartzite, marine shell. So again, this is something that is pretty well known to historians and archaeologists. Just have to toggle here. Okay. The other thing is, of course, that people like Bruce Trigger have described this in detail as well in terms of, for example, the Huron, the Wendat, the Algonquins in the Ottawa Valley. We know of a series of pre-contact trading routes and, let's say, travel routes in the Northeast here. These are primarily, as you can see, along the Ottawa River, Upper Great Lakes, Lower Great Lakes to New York, and then up to James. So this is from Bruce Trigger's book, Children of the Pensic. Again, these are things that we've known about for quite a while, that First Nations had pretty extensive travel and trading routes across the Northeast. So basically, my talk tonight will be divided in 4 parts. The first part is sort of more the science part, the archaeometry part, which is, how do archaeologists actually figure out that objects and materials have been moved over large distances in the past? So how do we do that with precision, with accuracy? The second part is basically how do we reconstruct the social networks that made the movement of people and materials possible? That's the more anthropological part, if you want. The third part are the actual archaeological examples. So I'll give you 3 examples of my work from different periods. And then I'll finish up with just some implications or conclusions on what this tells us about Canada sort of before and after contact. So how do archaeologists know for sure, like with true accuracy or on a scientific basis, if a rock, for example, comes from a certain geological formation or an actual quarry, or let's say a material like copper? They use a series of analytical techniques. These are techniques that are borrowed from chemistry, physics, biology, geology, material science. We commonly refer to these as archaeological sciences or archaeometry. And this is a whole part of archaeology or subdiscipline of archaeology that is really grown a lot in the last 20 years. It's constantly expanding. There's several journals dedicated to it. And so there's, in fact, it's very hard to really summarize all the techniques that are used. Tonight, I'm primarily going to be talking about techniques from geology, so things like petrography and geochemistry. So specifically, how do I go about my work? Well, I do a lot of work that's basically geological. Sometimes we refer to it as geoarchaeology because it's basically a combination of geology and archaeology. Typically, what I do is I start out in the field actually doing geological field work. So what that means is I get geological maps and reports. I look for certain geological formations. I study them. I plan field trips where I can go visit outcrops, as you can see there in the top left. And I go to these outcrops, and what I do is I take samples. So as you can see here, I have a rock hammer, and I take samples of this rock. These rocks are then taken back to the lab, and they become part of a lithic reference collection. So we create a comparative lithic reference collection. There are several in Canada and the US that are well established, Jack Holland's in Buffalo, and in Ontario, Peter Von Bitters, and also Bill Fox had started when he was when he was at the Ministry of Transport. So there are many different lithic comparative collections. We have the Collection de référence lithique du Québec that was started by Yvon Coderre, and I've been adding to that. And so what I do is I add large samples. These are large samples. I need big samples because I need to be able to see the variability in the quality of a rock that's going to be used to make stone tools, to see if, you know, what's its, is it all good? Is it only 10% of it is useful? What's the variation in colors? How does it change when it weathers? As you can see here, this is Munsungan chert from the quarries at Munsungan in Maine. And you can see that when it weathers, wow, it turns almost white from a dark gray. The next step is I do something that geologists always do, which is I make thin sections. The thin sections are used to do a petrographic analysis. And this is essentially allows us to look at the rock, the mineralogy, the fossils, if there are any, the structures in the rock. And this is really the best way to characterize a rock on the sort of microscopic level. And I would say that in my experience, even though it's really good to do the first three steps at the top here, so in other words, to do the field work and recover really good samples for our reference collection, I have found that over the last few years that making the thin sections has really helped me to even better understand the rock, and sometimes to even understand actually why a rock might be better or worse for making stone tools. Sometimes things that you don't see in the hand sample, the larger sample, you can see in the thin section. The next step is to go to geochemical analyses. So this is another thing that I've been doing quite a bit for the last 20 odd years. What this represents here is simply a ternary diagram, in 3 dimensions of the concentration of silica, aluminum, and calcium in a rock. And what we're doing is we're trying to, again, characterize rocks, but in this case, based on their chemistry. And to do this, in my lab, we use X-ray fluorescence spectrometer. It's a pretty powerful machine that allows us to really get a sense of the chemical makeup of a rock. You can also do other things. For example, you can take this thin section here and polish it and put it under a scanning electron microscope, which then allows you to look at the thin section, but in a different way. And what you see here in the lighter and darker areas are different minerals, and you can actually put your crosshairs on a mineral and get the chemical makeup of that specific mineral and sort of get another geochemical profile, but of the minerals. It's a different way of looking at this thin section that you see. So all of these techniques together really give us a very good idea of the rock, right from the microscopic and even the chemical makeup, so almost the atomic level, right up to what it's like in the field when a person in the past actually went to that outcrop and tried to get a block of that material out of there and start make a stone tool. All right, so The next step is, of course, how do archaeologists reconstruct the social, networks that I'm talking about? Um, we can rely on ethnohistoric documents, early accounts of travelers, anthropological models of trade and exchange, First Nations oral traditions and toponymy. We can also use First Nations cartography. It's actually quite extensive. Human geography, of course, GIS, any other technique or let's say analytical approach that will allow us to understand how people move over the landscape. So, for example, here's a couple of examples of maps. I mean, on the left you have a map of the portage route from the Gulf of Maine and the Bay of Fundy to the St. Lawrence River, and it's de Nonville who drew this map, but in fact it's all based on information that was given to him by the Maliseet, the Etchemin. And on the right is, for example, a map drawn by a Passamaquoddy person in the 19th century of sort of how he went into inland and camped and hunted moose, etc. Another example, for example, here on the on the right is a map of Aboriginal trails, pre-contact trails through New Hampshire. So not only do we know quite a bit actually about trails, overland trails, as well as, of course, portage routes and rivers. It's surprising actually how much we know about this. And often these are actually published in 19th century documents. They're not recent documents, but if you look, you'll find them for New York, and you'll find them for Maine, and you'll find them for lots of regions. Another possibility is, of course, to use geographic models and just sort of look at, okay, how would I get from point A to point B? This is a GIS model where you take sort of elevations and you start from a point here. So this is a quarry of chert in New York in the Hudson Valley. And the question is, okay, we know that this chert was found at this site. We know it was found at this site, at this site, at this site, this site, this site. Now, how would I get from here if I went to get this chert to here? And so we can use what are called least cost paths models, for example, to look at how people move over the landscape. It's just a model. It doesn't actually tell us how it got from point A to point B, but it's still interesting. But I guess maybe the more important or the more interesting aspect is like I said, really the more shall I say ethnographic dimension of how these materials move over the landscape, and sort of what I find kind of most interesting, or motivates a lot of my work, is to understand why people want to travel and why they want to exchange objects or materials. There's a lot of reasons, obviously, that are written down and described either by early travelers or by First Nations people. Obviously, one of the most obvious one is the first one here is to access materials that are not in your own territory. So something that maybe you don't have in your own territory. Let's say, for example, that you'd really like to have some kind of a seal skin, but you live in the upper St. Lawrence Valley. Well, you'll trade with a group further down the valley towards the estuary to get some seal skins, something that you can't get where you live. That seems pretty straightforward. There's also just the fact that sometimes people just want stuff that they're curious about, things that are just they don't see in their daily lives. And this is something that any flint napper will recognize, because when you go to a nap-in, if somebody shows up with a material that somebody else has never seen, they always want to get some and try it. And so people are curious, of course. There's other models that people have talked about for years, like risk reduction. So if you maintain social networks, if you're hunter-gatherers especially, it's good to maintain these sort of networks through exchange, because when things go bad, you can maybe rely on your neighbors. You can also, there can be other things that motivate people to travel and obtain materials. It can be for prestige. I mean, people clearly went out of their way at Allumette and Morrison Island to get a lot of copper, hundreds and hundreds of objects in copper, and then make copper objects, pounds and pounds of it. And we know that copper was a powerful material. It was considered to have strong power or medicine, and so it is possible that it was motivated. Some of this movement of materials was motivated by that, by the fact that these materials were very symbolically important to people. Some other people have even mentioned the access to secret knowledge. This is mostly models from Europe, but there's no reason to believe it wouldn't apply here. Even pilgrimages. You know, we talk often of pilgrimages in the old world in Europe, but Christopher Carr has suggested it for example, the Hopewell, and people going to far distances to make pilgrimages or vision quests. So there are a lot of reasons that materials could end up on a site that come from far away, and obviously, sometimes for the archaeologist, it's actually pretty hard to tell what's really the reason, the actual, not just the motivation, but you know, the mechanisms that brought that material over such a long distance. Just get back to here. Okay. So one thing though that's worth looking at though is just to look at maybe what we might learn from anthropology, for example, is that if you look at that are pre-state societies, I guess, societies that don't necessarily use money and don't have a market system of exchange, so they might they don't have any currency, let's say. Why do they maintain trade networks? Well, most anthropologists seem to conclude that it's to maintain or extend social networks, maintain and extend social networks. So if you look at some of these classic ethnographies about pre-state economies and the exchange or circulation of materials, a lot of it seems to point to alliance building, and that these alliances are based on reciprocity. So the reciprocity being, I give you a shell bracelet or a shell necklace, and you give me in return perhaps a sealskin or something. This reciprocity is really the foundation of these alliances, and the reciprocity in this case takes its material form in the circulation of rocks or stone tools or copper tools or other things that we might find on our archaeological sites. And closer to home, an example that obviously a lot of people in Ontario know well is the extensive ethnohistoric documents on the Huron-Wendat. And what's again very interesting is whether you re-trigger Heidenreich, Tooker, or you just listen to traditional oral histories. Again, it's hard to not come to the conclusion that a lot of trade and exchange is used to maintain extensive social networks among groups, among, for example, communities like villages, to create those confederacies, and then of course between nations as well, and across confederacies and then beyond. So we're talking about not just diplomacy, but also it can be sort of just between villages, for example, on that scale. Sorry. Okay, so that's kind of more the shall we say the science part of it and the anthropological part, and now I'll get into sort of the archaeological examples of sort of how, what I worked on to connect what we find on an archaeological site with where that material might come from. And I'm going to present three different examples from the three different periods that I've worked on. And anyways, hopefully they'll be interesting to you. I've chosen ones that are close to home primarily, so hopefully of interest to members of the OAS. So the first one is based on work that I've done even just recently, I'm still completing right now on late Paleo-Indian sites. in the eastern townships. And these are sites that are dating roughly to, 9,000 years ago. It's unfortunately, we don't really have radiocarbon dates for most of these sites, but we do have a good sense of their dates based on, as you might imagine, the form of these points, which we call St. Anne Barney points. They're classic late Paleo-Indian points made with parallel retouch. And you can see examples here also. So this is Kruger, this is Godreau. These are two sites that are close to each other. And I've gone through all of the lithic materials for these sites and tried to essentially figure out where those materials are coming from. And so essentially what we're looking at here is a map of the area. The two sites that I'm going to be talking about are Kruger 2 and Godreau, and there's a third site too, Clichancourt. It's an early Paleo-Indian site, but it has some late Paleo-Indian components to it. So I've looked at all those collections in detail, the tools as well as the debitage. And basically what I've done here is I'm showing you what I think are within reasonable distance, all of the confirmed or potential sources of stone tool raw material that we find at these sites. Now, obviously, there's quite a variability in the materials that you see on these sites. There's bifaces drills, side scrapers, and scrapers, and there are actually quite a few materials being used at these sites. Some materials, however, dominate definitely more than others. There are materials that are from known sources that we can easily identify, like this Mount Jasper rhyolite that comes from New Hampshire. There's other materials that we have yet to identify their source. So for example, this is what was referred to as a rhyolite up until recently, but in my latest publication, I've come to the conclusion that it's an immature silicified sandstone, basically. That's through looking at thin sections. And I've spent a lot of time in the field trying to find the source of this material, many, many days in the field doing geology, and I have yet to find it. But I'll show you a couple of ideas I have about where it might come from. There's hornfels, for example. So these are bifaces. As you can see, the hornfels weathers terribly, and you can't even see sometimes the flake removals after a while. I'll mention where I think those are from. And then there's some local materials like this red silicified mudstone. And what's interesting is that for a while, we knew it was probably not far away. And last year, I found the quarry where this material comes from. It's the first prehistoric pre-contact quarry that we have in Eastern Townships. And I found it thanks to the work of an amateur and avocational archaeologist, Sylvain Rancourt. So if we look at, for example, that material, and I won't go through all of the steps, but just you have to believe me that I have actually been to every single one of these quarries, and I have gathered the geological samples myself and cut them out and made the thin sections and done the analyses. Essentially, what happened, the conclusion that we can come to, for example, for these sites is that you have a series of local materials that are essentially found in cobbles in the river, and then quartz that's probably coming out of local veins, and then this local red mudstone that is coming from this new quarry here that's called Makwapskok Rancourt. That's the Abenaki name for red rock, and Rancourt is Sylvain Rancourt, the avocational archaeologist that led me to the quarry. And so that is a lot of the material at those two sites. But then there's an awful lot of material, primarily bifaces, that are coming out of the east. So they're primarily out of the rhyolites in Mount Kineo, Brassois, Blue Ridge area of Maine. As you can see, it's pretty far away. It's 150, 200 kilometers away from these sites. That's not terribly far for Paleo-Indians, but nonetheless, it's a considerably distance. And then there's other materials that might be at the site, such as Montagne de Mount. Ledge ridge is not present at these sites. I can confirm that. And then, so the question is, okay, maybe that's sort of the territory of this group. But then the problem is that we also have other materials from Vermont, like quartzite, Hathaway chert, and possibly that unusual material that I was showing you that we thought was the rhyolite that now we think is a immature silicified sandstone. And we have a couple of sites now in Vermont that we think maybe are pointing us to a source in Vermont. Now, the question is, would a Paleo-Indian group have a territory that's a late Paleo-Indian group have a territory that's this big and then another one going here? I'm not sure right now. My conclusion in the chapter for the Kruger book is that maybe there's actually groups that are meeting here, 2 different groups. And then there's other materials that are present also at the site, like that Mount Jasper rhyolite, that rhyolite from New Hampshire, that is only present in 2 or 3 tools. And those, I think, were probably obtained via exchange, that is, through a secondary group, maybe this group in Vermont that got it from this group in New Hampshire, or some other interaction over in Maine. It's hard to tell. So in this case, we see a use of local materials and then a preference for materials, for example, from Maine, but then also a significant presence of materials that are coming from Vermont. And the question is it one big territory, or is it, for example, 2 groups? That's something that right now is actually a hypothesis that we have to work with, and we cannot give a definite answer. The next example is one that I'm sure many of you are familiar with. It's Îles aux Limites and Île Morrison. That's just up the river from Ottawa. I worked on this for my postdoc, so that was a while ago, almost 20 years. I was able to go through all the lithic material for those 2 sites, including also the polished stone tools. But I did not do the analysis of the quartz. That was done by Yves Chrétien. And again, what's interesting about Allumette and Morrison is that, not only are they amazing sites because they're so big and they have everything that you'd ever want and a lot of them. So not only do you have Otter Creek points, but you have 20 Otter Creek points. Not only do you have Brewerton points, but you have, all kinds of Brewerton points. And the ones that look exactly like out of Ritchie's book and other ones that don't look quite as good. So these are amazing sites that are, like I said, very rich. But my job was really to look at sort of where was the material coming from. So Allumette is known for having hundreds of tools made out of copper. The question was, where does that copper come from? Greg Kennedy did the neutron activation analysis. The math related to your copper. It makes sense because, of course, anybody that looks at these shapes will recognize shapes that are known from the Great Lakes, from what used to be called the old copper culture. But then there's other forms that are more typical, sort of more specific to Allumette Morrison, like these conical. So my job, though, was to kind of look at everything else. So those fragmentary pieces of tools and chunky bits to try and see what was present at the site. And there were materials that were easily recognizable. Many of you recognize, for example, this piece here is the Onondaga chert. But then there's other materials that are maybe less recognizable to some of us. Some of you will probably recognize Kettle Point, maybe possible Hudson Bay lowland. And so my job was to go through all of these, make thin sections where I was allowed to by the Canadian history. But mostly it was done comparing it to a comparative collection and then doing some geochemical analysis. We had quartzites, we had hornfels, various igneous rocks, and then some sort of local regional rocks that people had called metaquartzite, but turned out that when we did a thin section analysis and looked at it, it was a fault rock, so a rock that's found in a fault zone, like a myelinite, for example. And so what was interesting to look at was another interesting aspect from an archaeological perspective was to see that these people who were related to what's called the Laurentian Archaic in the Ottawa Valley were making the same tool forms in different materials. So this is an Otter Creek point made out of Cheshire quartzite, which is the classic material for Otter Creek points because the Otter Creek site is in Vermont, where the source of Cheshire quartzite is. But then you have a Hornfels Otter Creek point here that's made from the Hornfels in the Mount Royal Quarry in Montreal. We have a point here that's Otter Creek, but made out of the local rock. And then this is more of a side notch Brewerton, but it's made from chert from Southern Ontario. So what they're reproducing the classic forms, but in local materials, regional materials, imported. You know, they're trying to copy the forms that are coming from, let's say, the east or the south with materials that are local as well. And that's kind of interesting because it shows that they're really participating directly in this sort of Laurentian archaic, shall we say, interaction sphere or cultural sphere. So again, I had to do quite a bit of geological background work, get to know the Ontario cherts better. Went to look at them with Peter von Bitter, got a lot of help from Bill Fox, of course. And then, you know, based on Elian von Bitter's work as well, that helped a lot. And then also just had to get comparative samples from all of those cherts. And so the big picture sort of summary was this. This is published in the Willamette book, but essentially we have copper that's coming from the Great Lakes. It's a very good match for copper from the Onondaga Peninsula and Ile Royale, the classic sources known for the Archaic. So that makes sense. There's some quartzite from Manitoulin, from Shigwinda, very little, but there's also probably some chert from Manitoulin. And I suspect that in fact, this material, the copper, is coming via Manitoulin, and then some of that quartzite and chert is just being picked up and brought along, probably along the French River and North Bay portage routes. Then there's a series of cherts from Southern Ontario that many of you, I'm sure, are familiar with. There's Fossil Hill, there's Kettle Point, not much, but it's there. There's the cherts like the Onondaga and the Dundee from further south in Ontario. And these are showing up at the site in finished, basically point form. They're points that are finished. We find very little debitage, so they're arriving already in their finished form, retouched a bit, used, and then abandoned. And then there are some materials coming from the east, so from the lower Ottawa Valley, from Mount Royal. That Hornfels is coming from the quarry at Mount Royal on the island of Montreal. And like I mentioned, a bit of Cheshire quartzite, which makes sense because the Otter Creek points, the classic Otter Creek Laurentian archaic points, are originally made out of Cheshire quartzite. So there's a connection to the east as well. There may be material coming from Healy Falls in the form of axes and adzes. There was material that was similar, but only a couple. A lot of the sort of slate material in that, I'm not sure where it's from. Could be from a series of various different places. So clearly from this map, you can see that the people at Willamette and Morrison, far from being isolated, are well connected to this Laurentian archaic world and even to the upper Great Lakes here and to what is referred to sometimes the old copper culture. And they're clearly connected to the west, to Southern Ontario groups, and even down the Ottawa Valley to Montreal. Possibly the Cheshire quartzite is coming via Montreal. I wouldn't be surprised. So another interesting thing was I found no materials from the north. So originally I had expected to find maybe some Mistassini quartzite, maybe some Hudson Bay lowland chert, but I did not find that material at Willamette and Morrison. So that's kind of interesting because it suggests that maybe the connections are not established, or maybe their people aren't there yet 6,000 years ago, or as you can see here, the dates roughly 6,000 at most, 6,100 before present. There seems to be very little or no connection to groups in the north at this point. So these people are looking to the south. That's where their, shall we say, their cousins and their closest social relations are with groups in Southern Ontario, possibly groups to the west, but the copper is probably being exchanged via some other group in between, somewhere perhaps in the Lake Huron, Georgian Bay area. And then, of course, some connections down the Ottawa River. All right, moving right along. So, because we're running out of time. So the third example is much more recent. This is comes from 3 different St. Lawrence Iroquoian villages in the upper St. Lawrence Valley, so very close to New York and Ontario, right in that little wedge there of Quebec. And I'm talking about these sites right here. So MacDonald, Drulers, and Mayut Curran right here. And there, so here's the St. Lawrence. Here's some of the very well-known St. Lawrence Iroquoian sites on the Ontario side. Here's a concentration of sites in Jefferson County. That's for you, Tim, because I know Tim Abel's listening today. So I was able to look at all of the lithic material from these sites, about 6,500 artifacts. Let me just start by saying that analyzing lithics from St. Lawrence Iroquoian sites is kind of a thankless task. It's not the pretty objects that you see for the Archaic and for the Paleo-Indian, but nonetheless, I did it with some trepidation, but I learned a lot from it. And what's the first thing you notice is that there's very few finished tools, very few finished formal tools on these sites. I mean, an entire village of 300-400 people might have 2 or 3 points on it, literally, for an entire village. And these are villages where our field school has excavated just complete longhouses, several complete longhouses. It's not that we were just doing little test pits in there. So there's definitely a lack of formal tools. Some of them are in materials that are easily recognized, like the Onondaga chert. This is a material from the Upper St. Lawrence, what we call the Ray chert. That's from the Watertown area in Jefferson County. But you know, there's actually a lot more going on these sites than just those odd tools that are clearly imported. And so there's 3 different categories of tools. There's pecked and groundstone tools, which are actually probably much more important in daily life for these people. Some chipstone tools, debitage, and then there's beads and pendants. So I'll just show you some pictures very quickly of those. Here's some of the pecked and ground polished stone tools. Mortars, grinding stones. So beautiful grinding stones in sandstone. Some mullers and manos, or hand grinding stones, some abrading stones, and a few axes and adzes. Relatively small compared to the ones you see in the Archaic. Some chipstone tools, but as I said, this is the entirety of all the bifaces from the Druler site, for example. The Druler site is a large village. And you know, it probably has 300-400 people on it at least, and yet this is all of it for the points and bifaces. There's some scrapers, but they're ugly for the most part. They're made out of all kinds of materials. There's wedges, sort of bipolar pieces. And then there's actually quite an interesting, important industry, I would say, of soapstone beads, steatite beads, and then the odd pendant and ornaments. And when I looked at, again, I looked at the geology, I got the comparative samples of the different materials, whether it was from northern New York or, for example, we did a very extensive sourcing project for the soapstone, looking at New York sources, Quebec sources, Ontario sources, and we got help from Tim Abel and from Bill Fox. For example, we went and looked at all these sources, got the comparative samples. We did, in some cases, thin sections, in some cases, just a bit of geochemistry. We weren't able to do that on every piece. But in the case of the St. Lawrence Iroquoian villages, what you see is basically almost all tools are made from local materials. In fact, they're local cobbles for the most part that originate in tills or riverbeds, so they're found within 10 kilometers of the site. And they may be actually quarrying out some of the sandstone to make their larger grinding stones, and I think I found the source for that in the Potsdam sandstone or the Cairn side. I did a bit of field work and found some very nice sandstone in the immediate vicinity of some of those villages. There are some regional materials that come from bedrock sources, hornfells, and like that sandstone that I mentioned. There's a few imported finished tools, but they're really pretty rare. But they come from all kinds of places. They come from New York, they come from Vermont. They come even from Maine. And then there's of course all those beads. There's quite a few beads on these all three sites, and they're made out of soapstone. And when we did the geochemistry with Anne Baron, who was a postdoc from France, we did the geochemistry and we got samples of soapstone from Vermont, from Quebec, from New York, from Ontario, and we did the geochemistry. We found that the closest match was really to the soapstones that are found in northernmost New York and in Ontario, right northwest of Kingston. And I'll show you a map now just to give you an idea. This is just to show you that when you're on these sites, that you have to do your sort of basic geology background work. And the problem in the St. Lawrence lowlands, for example, in this area, is that there's almost nothing that you can really make stone tools out of, except for like the sandstone, which is quite good for grinding stones. Otherwise, you might pick up whatever you can find in river cobbles. But there was some chert that was found in the tills, which is interesting, and that's something of a mystery still, what the source of that is. So this is just a kind of overview of what are the materials that these people are using on these sites. Well, for the groundstone tools, they're using sandstone and granite and gneiss, grey-whack, siltstone, mudstone, shale, slate. That's all local, and then some hornfells from not too far away, and some amphibolite probably from the Adirondack. For the pendants, well, there's the steatite beads that are clearly from northern New York and southeastern Ontario, and then there's some shale that's used, so local shale. And then for the chipstone tools, it's even more varied. But again, sometimes we're talking about one or two pieces out of this non-local material. You know, if you're talking about Cheshire quartzite, there might be 2 pieces on the site. Rhyolite, maybe 2 artifacts on the entire site. It's mostly local material. There's a local grade chert that's found in the tills. It's not found in bedrock. It's found in the tills. There's quartz, local quartz. There's igneous rock that was found probably in cobble form, and then the local red shale, again, in cobbles. There's a local shale, so they're actually chipping it and then grinding it, and they're making all kinds of stuff out of it, which is pretty interesting because it's not easy to chip. They chip it though, but then they grind it and they make different things. I'm not exactly sure what this is. Probably some, pendants. This one is clearly a pendant. Little chisels, for example. You can see this thing measures only a few centimeters long. I'm sorry, it doesn't have the scale there. And then this is, for example, the hornfells. This is a material that's very common to the St. Lawrence Iroquoian sites and to the Montreal area and the upper St. Lawrence. It comes from the same quarries that I mentioned from Mont Royal on the island of Montreal. And it's worked both as chipped material, like bifacial and just reworked flakes, but also sometimes they chip it and then they grind it and they'll make axes out of it, which is interesting. So it's a material that's pretty flexible. And then there's also hundreds, in some cases thousands, of these quartz crystals. This is kind of a mystery. They almost certainly come out of these geodes that are in the local limestones. I haven't actually I found many geodes with calcite crystals, but not with quartz crystals. But what's interesting is that people who know, for example, the Herkimer diamonds from New York know that the Iroquois in New York were very interested and attached to those quartz crystals, and they exchanged them and kept them as heirlooms. And on this site, for example, the jewelers, we find tons of them. And they seem to be processing these geodes and trying to extract these small quartz crystals. And then the question is, what do they do with them? They're not necessarily working them. I thought at first they were trying to use them bipolarly, but they're mostly crushed on the ends. And what I proposed in the Drillers volume, the book that was published on Drillers, is that they may actually be used in rattles or to create what's called piezoelectricity, which is when you hit quartz crystals against each other, they make light. And I'm wondering if it's not possible that these are crushed because they were actually used in rattles, or people were hitting them on an anvil while trying to extract the geodes and the crystals. Anyways, interesting, something to talk about perhaps. So if you look at the sites here, these three villages right here in the upper St. Lawrence, what you see is essentially local materials like quartz, red shale, and sandstone that dominate. And these people are sedentary, they're horticulturalists, so they're not really very concerned with their stone tools. They might spend some time to make their grinding stones and their manos, their mullers, because that they use all every day, you know, on a regular basis. But they seem to have, for example, replaced a lot of their stone projectile points with bone projectile points, for example. And so they're relying mostly on local materials. They do use some regional materials. So if you look at about 100-kilometer radius, while you have the Mount Royal Hornfells, you have the amphibolite that's used for some of those axes, possibly from the Adirondacks. You have some steatite, but the steatite is actually mostly from more than 100 kilometers away. This is the sources in Ontario, and this is the sources in northern New York. The Lorraine chert, but again, it's only a few pieces. It's really very little. And then further afield, well, you have a couple of pieces of Chester quartzite, a couple of pieces of Hathaway chert from Vermont, and then a couple of pieces of Mount Kineo rhyolite, 1 or 2 points made out of Onondaga chert. Those were probably obtained through exchange with other villages. And but again, it shows that these people have exchange networks, just like for the soapstone beads, for example, that actually seem to be moving west as well. But they're in terms of the stone materials, it's mostly local stuff that they're using, and they don't really go to much of effort to get stuff from far away, like, for example, people during the Archaic did or during the Paleo-Indian. All right, so I think I'm right about on time. So just some quick conclusions. Basically, I think that as archaeologists, we can definitely show that we have material evidence for long distance exchange and interaction between indigenous communities that go back thousands of years, obviously. Some of these exchange networks actually last for generations. That's an important point to remind people about. It's not just a one-off. These things actually last, and they're maintained. So they're sustained social interaction networks that last through generations, and they're often between culturally, linguistically distinct groups. So, for example, the Huron, as you may know, maintained very close relationships with the Algonquins and other groups groups around them that were socially, politically quite different from them. And I guess my point is that a lot of these networks were, at least in part, underwritten by the exchange of raw materials and objects, that in this case, what I've presented today are primarily in the form of stone tools and stone tool materials. But you know, it could be in the form of other materials that obviously aren't preserved. And I guess this is my little pitch for the end here, because I think it's what's interesting to do is to note is that as archaeologists, we can contribute also to sort of our better understanding of the history of Canada before and after the creation of this country, and or Canada, for example, or Ontario, Quebec. Because I think that this shows that there were these extensive networks between communities and nations that persisted over generations, over large distances. And obviously we knew that for the Huron-Wendat, as we saw in the example from Bruce Trigger's book, but we have lots of data for lots of different periods and areas that show this. These networks they were sustained, and they were underwritten by regular interaction and exchange of goods and raw materials and people, probably, and ideas. These networks, they came and went over the centuries and the millennia, so we can see them sort of wax and wane. Some of them become important, and they're primarily east-west. Other ones then change, and they may be more north-south. But they're always sort of replaced by other networks that sort of come into being. And of course, at the time of European contact and colonization, when these networks that were already existing for generations, millennia, well, they represented a cultural geography and a sort of a geopolitical map that I think was already well in place in Canada, and therefore into which the European powers had to insert themselves. And of course, it had, as I think, a structuring effect or an impact on what happened post contact in terms of the sort of the geopolitics and the colonial history of those areas that today we call Canada or the US. Anyways, I guess that's it. Thank you, merci. And I guess it's time for questions, and I will stop this slideshow.